Let us solve this problem. A spherical balloon is being deflated and its radius is decreasing at a constant rate of 6 centimeters per second. At what rate is the volume of the balloon changing when the radius is 3 centimeters? Let us say this is the balloon and the radius of the balloon is represented by r. We are going to find the rate of change of the radius in terms of time. Since the radius is decreasing at a constant rate of 6 centimeters per second, therefore, dr over dt, or the derivative of r with respect to t, is equal to negative 6 centimeters per second. Negative because the radius is decreasing. Next, we are going to write the equation that relate to the variables. Since what is asked in the problem is at what rate is the volume of the balloon changing when the radius is 3 centimeters, therefore, the equation that relates to the variables is the formula for finding the volume of a sphere. The balloon is spherical. The formula for finding the volume of a sphere is V is equal to 4 over 3 pi r cubed. The next thing to do is to differentiate both sides of this formula. So we are going to differentiate the left side of this formula and then the right side. So we have now dv over dt, or the derivative of v with respect to t is equal to 4 over 3 pi times 3 r squared dr over dt. We can cancel 3, this 3 with this 3 in the denominator. So we have now dv over dt is equal to 4 pi r squared dr over dt. The next thing to do is to substitute 3 for r and negative 6 for dr over dt. We have now dv over dt is equal to 4 pi times 3 squared times negative 6. This is equal to negative 216 pi. Multiplying negative 216 pi by the value of pi, we get negative 678.6 to the nearest 1 decimal place. So the volume of the balloon is changing at the rate of negative 678.6 cubic centimeters per second.